So today we'll see that client server communication concept.
Okay.
So today we'll see that MQ client server communication. So far we have seen that queue manager to queue manager communication. So if they wanted to communicate one queue manager and another queue manager, we'll create that messaging channel and we'll able to communicate between the two queues. Now if I have a requirement, so an outside environment application or within the environment application, they want to use the client mode to connect it to the queue manager. When they wanted to use this MQ client mode, here whenever they don't whenever that application doesn't have a much software or hardware infrastructure, or they need only that MQ functionality to put or to get a message, then we will advise to that team to use only MQ client system. MQ client is a small component. It doesn't have any objects like queue manager, queues, listeners, nothing. Doesn't need to install so much hardware also. So much software also doesn't require actually. It is a small component. It needs maximum is 50 MB space is required. So whenever that MQ functionality is requesting by the application, they wanted to use only either put or to get a message. Okay, they don't want to store a message in the locally. Here we will use that concept called client server communication. Okay, when one application want to talk to the multiple queue managers. Okay, so within the environment or outside the environment, they wanted to use the queue manager to put or to get a message. So the concept which you are going to use is called actually client server communication. Here, so this is a one kind of diagram. So you can see that a client want to talk to the server. So we are going to use the channels called MQA channels. So MQA channels are the message queuing channels, which is a bidirectional channel, which is used for the to put and to get a message of the under queue manager. Queue manager also can able to communicate and they can able to put and get message. But here, if we want to install, if we want to create a queue manager, we require to install MQ server software. MQ server software have that we required so much hardware and there are prerequisites like file systems we required. Okay, so that required other prerequisites actually. So username, user ID we need to create, we need to add user to group member. So like that, there are so many prerequisites need to be configured at the even hardware level, even software level. But when you are going to install MQ client system, it doesn't require much prerequisite to install or to create. You can install by directly this client component, which is a small component only, this is a small library. You can use this MQ client library to communicate to the MQ queue manager. Here, if you see the client system, so there is a WMQ application, which is a client application. So client application having that client stub internally, it has that client functionality to put and to get a message. Now, if client want to talk to the queue manager, here the queue manager side, we have to define the server connection channel. We have to define the server connection channel. The client side, we have to set up the environment variable so that client will identify that one whom he needs to connect. By reading this environment variable, client will able to understand whom he needs to connect and what are the requirement, whether the requirement is put or a get message. So it can be done by the WebSphere MQ client system. Here these are the advantages. Even if you are using WebSphere MQ client also, we will provide that assured delivery and queue storage. Still we have the queue storage because it is connected to the queue manager and it will post message to the under queue manager queues. So under this queue manager we have the facility to storage your request. Okay. Now we have the queue storage also, data conversion also. See here, MQ client level, MQ client application is supporting for that one kind of uh, Arabic language. Example, Arabic. Queue manager will support only, for example, my MQ application is sending Arabic language. Here, queue manager has to be support. At the same time, queue manager reply back to the Arabic language. My application has to be support. Here, data conversion can be done. Data conversion can be done between the uh, application and a queue manager also. And administration is very easy. Here, administration is very easy. Even the recovery also possible. The request is sent to the queue manager. The queue is available to store the request. In case of in case of the queue manager is restarted, our system is restarted, still the request is available if the message is persistency. Next, sync point control. Within a unit of work, my application can able to put message, can able to get message. That is called sync point control. So here, the sync point control also available at the client level. You can able to get, you can able to put a message within the unit of work. So this is about the client advantages. How client will talk to the MQ? What are the different types of methods we have? Those methods are set MQ server method and channel table method and using the JMS code by configuring the channel details. So these are the methods. The first method is, sorry, not this one, here. These are the methods which you are going to use. My application, my client want to talk to the MQ. These are the different types of methods we are going to use. The method one is MQ server, environment variable on client side. So we have to set up MQ server environment variable. So this required, these are the different types of attributes. Connection name, queue manager name, TRP type, channel type. If any method you are going to use, at least out of 4, there are 3 required. Okay. So these are the, here channel type is as a server connection channel or client connection channel. TRP type is transport type, connection name and queue manager name. This is optional for the setMQ server mechanism, but the CCDT mechanism, the second one, client channel definition table, these 4 are the mandatory. Okay. Now we will see that first setMQ server mechanism. So how you are going to use setMQ server mechanism to connect to your MQ from the client. The second one is client channel definition table. The third one is encapsulated connection object in Java. Next one is external J&A lookup for JMS. These two will be using by the application level. So this one, if you see the Java, I mean to say a WebSphere application server, in WebSphere application server will create the J&A lookups. Okay. Using this J&A lookup, we are able to connect. Third one is our native application code. I think if it is Java application, core Java application want to talk to the MQ. So here we will specify that channel name, queue name, IP address and port number. So when you are calling the Java application, we will specify some libraries in the run file. So when you are going to start your application, in your run file, you will configure the libraries, right? So when you invoke we start a Java application, those MQ related libraries also will be invoked. Okay, we have to set up the environment variable. We have to set up the class path to start our Java application. Whenever you are starting a Java application, we need to invoke the Java application along with the MQ libraries. Okay, that information will be configured in the class path along with our IP details, connection name and all the queue manager related. So all this we will be configured in the Java application code level. So that is called third one. So today we will see the two different methods, MQ server mechanism and client channel definition. Another 3 and 4th will be using by the application team.
Ram,
Yeah.
uh, if there is like data power, MQ and data power, what you use?
That will use MQ server mechanism.
Okay. Then like for data power, what information you give?
We will give that channel type, TRP type, connection name.
Okay. There is only you will give these three things. That's it, no?
Yeah, these enough actually.
Okay.
Okay. First, we will create one queue manager and we will try to configure the set MQ server mechanism. So, shall we go through that command line?
Yeah.
Okay. So, let's go to that MQM, SU space hyphen MQM. Now, verify the is there any queue manager running? Yes, there is a queue manager. Let me start the queue manager. strmq queue manager B. So my queue manager is being started. Now let's go to that run mqsc qmb. So first we have to define the listener first. Verify is there any listener is running or not. Yes, there is a listener called qmb.tsc which is listener. The port 1415. Verify the listener status. Yeah, my listener is running with the 1415 port number. So let's create a channel called server connection channel. Define channel. My channel name is test.svr. Channel type is SVRCon. MCA user is MQM. This is enough. Just enter. So my channel has been created. Now we need to give the channel name to the application team, whoever it may be, either data power or anybody. We will give it to them. Now application side, he will try to use that set MQ server mechanism and he will connect. So I am going to use my Windows machine to connect it to the remote queue manager. So I am going to be set a environment variable here, set MQ server equal to my server connection channel name is test.svr. Here transport type is TCP, IP address is 192.168.152.134. 1415 is the port number. Yes, done. Okay. Now we will try to put message to the one of the queue under queue manager B. Let me define queue local qmb.lq is the queue. My queue name is qmb.lq. Now go to the command line of Windows and try to put message. AMQS put C. Put C is the sample application. So using this put C application, we can verify the client server communication. AMQS put C and queue name is qmb.lq and queue manager name is qmb. Let's try AMQS. Command name is AMQS. AMQS put C. AMQS put means our server to server communication, but AMQS put C means client. Put C. C is the client verification. Now I am trying to put message to the qmb.lq by connecting the queue manager B. I got the error called 2538. What is 2538? Host not available. 2538, which is a host not available. When you are getting the host not available means should telnet 192, 168, 152, 134 space 1415. No, telnet is not working. It means there is some firewall issue. Now you should send email to the firewall team to enable the firewall. Okay. Now firewall team enable the respective IP from your source system. Now I do not have a firewall team now. I am going to be disable the firewall from my side, from the Unix machine side. So now firewall has been disabled. Now let's try to telnet. It will work. So I do not telnet now. I am using directly AMQS put C. If it is connected, then fine, firewall issue resolved. Now I am getting 2035, which is a different exception. Firewall issue resolved now. I am getting 2035 unauthorized. He is not an authorized person to connect because MQ 7.1 version onwards, there is a new feature has been added that is called channel authentication records. Channel authentication records. This authentication will verify that one whether that incoming connection from outside to my queue manager, incoming connection, he is an authorized person to connect my queue manager or not. Because if he is not authorized, if the particular person or particular application level, is there any channel authentication record has been created or not, that will be verified by the queue manager level authentication concept. Now queue manager level authentication concept will allow only that this particular IP is allowed to the queue manager. We need to configure at the channel authentication level. We need to allow the outside application, outside incoming address, whether he has the permission or not. If he is not permission, then it will not be allowed. If he is added to the part of the channel authentication record, this particular IP, he will be allowed. Okay. So for time being now, I am going to disabling the channel authentication records. So I will explain in the coming classes channel authentication record, the security concept. For time being, I am going to disable this channel authentication record by logging to the queue manager Now I have a command called display QMGR CHL auth channel authentication records. It is enabled now. Channel authentication record is enabled now. I am going to disable this one. Alter QMGR CHL auth. It should be disabled because of if it is enabled means outside connection not allowed until you added this outside IP address to your queue manager. Currently I have not added, so I am disabling this complete feature itself. So now anybody can able to connect to your MyQ manager. Here security concept we are disabling. We are violating our security concept, but still anyhow I wanted to connect my outside application to MyQ manager. So I am disabling this property without giving any permission. Okay. Now let's try to connect.
And this is a control command or
This is run MQC.
yeah, run MQSC and you put the queue manager. That's why like it knows like for only this specific queue manager you are disabling the authentication.
Correct. You are right.
Okay.
Now let's try to put message. Yes, I am able to put message now. If you enter 2 times, it will be disconnected. Now let's go and verify by checking the queue depth. See now, I can see the current depth is 1 now. When this message has been sent to this queue, any idea how to check that one? So when the message has been reached to this queue, we can alter the mon queue. This is the mon queue attribute need to be altered so that you can able to see the queue last put date and get date. Now see that here I am able to see now last put time and last put date. When this is just now, some time back we have pushed the message. Okay, it was delayed 2.5 hours because I am using this Saudi time. Okay, so if your application has been picked by the if your message has been picked by the application, this time will be updated. Last get time will be updated.
If there are like 10 queues.
Sorry.
If there are 10 queues, like 10 messages.
Yeah, it will display 10 message. Last message put date will be displayed. Last message.
Okay. Okay.
Now I am receiving the message. I am trying to read the message. Now go and verify. Yeah, last get date will be updated. Last get date and get time will be updated. See now, last get date and has been updated. You always we need to verify the last put date and get date. Last get date is it should be always that greater than last put date. Then only you can confirm that your application is picking the message. The last put date is the latest date. Last get date is the old date means there is some application issue. Application is not picking the messages. It might be hung state or something, or maybe yeah, mostly it will be either it is a stopped status or it should be a hung status. If it is a stopped status, IP proc should be 0. IP proc means who is reading the message. OP proc means who is putting a message to the queue. Mostly putting a message should be the channel, because when you are using intercommunication, channel only will put message to the destination queue, right? Receiver channel. So almost OP proc should be the channel name to whom where you are receiving the message, which application is sending a message to this queue, and IP proc means the local application who is receiving the message. If the local application is stopped means IP proc will be 0. So IP proc 1 means one thread is listening to this queue. If it is 10 means 10 threads are listening to this queue. At a time only one application can able to connect. Okay.
ఒక్కసారి ఇంకోసారి చెప్పండి ఇది ఐపీ ప్రాస్
IP proc means who is reading a message. Who is reading a message? Either it is a client or either it is a local Java application or local SAP, whatever the application which is SAP application or SAS, whatever it may be. Who is reading a message? Either it is locally or remotely. If they want to use remotely reading means like this. I have set up environment variable, right? So by reading the MQ's get C command, I am trying to read the message. Okay. That is IP proc. IP proc will always show you that who is reading a message. Okay. OP proc will show that who is putting a message. Okay. So when you are seeing that OP proc 1 means mostly from the channel only the message will come. So the channel level it will specify the connection name in the IP address from which source or which server where someone is putting a message. So that IP address information will be available.
Where we can check that?
Yeah, I will show you that. Okay. I am trying to put message now. Okay. Now you are able to see here one OP proc is there, right?
Yes.
Now I want to see that who is putting a message, from which IP I am getting a message. You should write command called type handle all where output equal to S. Output is wrong. Output equal to yes. This is the command. Who is putting a message will display. This one. This IP I am sending a message. Okay.
Okay.
Now we want to see who is reading a message. If you want to use same command, it will not work out. Just type where input equal to share.
What your DS display QS is what is that QS?
Queue status.
Queue status. Okay. And queue status and you are giving the local queue name.
Yeah. See, currently nobody is picking the message because already he has read the message. He has connected and he has read the message. Now let's try by reading message once again. Because I should type this command immediately. Then only see now I can see that someone is reading a message from this IP. Input equal to share. The first command I have given is output equal to yes. See now here output equal to yes. So these two commands if you run, you can know that who is putting and who is getting a message. Just type these two commands, okay? If it is not found means status not found means nobody is listening to this queue. Okay? Understand, Mahesh?
Yes.
See my application also it display AMQ's get C. So who is reading message? AMQ's get C is an application is trying to read. Who is putting message now? It will display here. Here AMQ's puts in application is trying to read a message. What is the channel we are trying? Test.svi. What is the connection? This is my source. This is my Windows machine IP address. Okay. So he is trying to put message. My IP config. So where I am getting? This is my source IP address. 192.168.1. 152.1. This is my source IP address. Ethernet source IP address. He is trying to connect. 192.168.150.1. Okay, this is about the setMQ server mechanism. So you understand this concept, setMQ server mechanism. Now let's see that channel table definition. So what is the difference between the setMQ server mechanism and channel table definition? So let me try a small diagram here to understand this. Now I have a client. Now I have a queue manager. Here my client is talking to only one queue manager. So what we did now, we did the channel setMQ server mechanism. I mean it's a server environment variable we did actually. Now to here I can talk one application only to talk to only one queue manager. If we want to connect it to that different queue manager, again I have to override the existing configuration of the environment variable. Okay, here I am not able to talk to the multiple queue at a time. To override this issue, to overcome this issue, we are going to use the concept called CCDT, Client Channel Definition Table. So using this client channel definition table, we can able to talk to the n number of queue managers. So CCDT will overcome this only one-to-one communication. Now CCDT it has the capability to communicate. One client will talk to the multiple queue managers. One client or one application will talk to the multiple queue managers. Okay, how you are going to achieve this CCDT mechanism? So what we will do now, I have now 3 queue managers. For example, this is one queue manager, I have one more queue manager. So A, B, C are the queue managers. Otherwise queue manager 1, queue manager 2 and queue manager 3. These are the 3 different queue managers. Let's try connect into the queue manager 1. Let's try queue manager 3. Now queue manager 1 want to talk, my client want to talk to the 3 different queue managers. So we need to set up the client channel definition table. So what is this client channel definition table? Here we have to create each queue manager server connection channel. My server connection channel name is qm1.svr1. Here qm2.svr, we will make it svr only, and qm3.svr. So they are the 3 different queue managers. qm1.svr. First, each queue manager we have to define the server connection channel, and now we have to choose one of the queue manager under these 3, and we have to create a client connection channel also. We have to create the client connection channel. So in a production time, in production environment, we will choose a which is a geographically middle to the client. So here QM2 is the middle to the my client system. Okay, so I am going to be create my client connection channel under queue manager 2. Under queue manager 2. So all 3 related queue manager client connection channel we have to create only at the one queue manager. Now here what we have to do now? Here we have to create a client connection channel with the name of server connection channel only, qm2.svr, qm3.svr. So we have to create 3 different types of server client connection channels and specify the, while creating a client connection channel, there are attributes like con name and QM name. We have to give this connection name. QM1 and SVR connection name is the respective queue manager 1 IP address and port number and queue manager name. QM2 con name is QM2 IP address and port number and respective queue manager. QM3 also same. So while creating a client connection channel, we have to make sure that server connection channel name and client connection channel should be the same name, and we have to give the respect to IP address, port number and queue manager. Okay. Now client connection is ready. So once you define this client connection channels and server connection channel, under the /var MQM, under the queue managers, under QM2, there is a folder called @IPCC. @IPCC. Under this folder, there are channel table will be created. The channel table name is AMQ CL.tab file. So this is a tab file. Under this @IPCC folder, it will generate it. Now we need to copy this. We need to send this tab file to the client system. Now a client side, he will set up the environment variable. Now what we have to do now? We have to copy this one. We have to send to the client. Now client will set up the environment variable by running the two commands. One is that set or export. Because if it is in a Unix system, we have to use the export command. Export MQ library equal to path. The path of the AMQCL tab file is existed. Export MQ library. Export AMQCL library. AMQ, I think so. AMQ. Export MQ library. Export AMQ. 1 second. I missed out those two commands. Yeah. Here, this MQCHL library, MQCHL tab, MQCHL library, MQCHL tab equal to the tab file name, AMQCL tab file. So we have to run these two commands so that a client side now environment variable will be set, and he can able to talk to the any of these three QMA at a time without touching any others. Understand, Mahesh?
Yeah.
Okay, let's create a three queue managers. I have already QMB. Now let's create CRT MQM QMA.
Like client side, they'll install like whatever the application, they should install MQ client software, no? If it's Java application or .NET application.
Yeah, we have to install MQ client software.
Okay, okay. For what purpose they install MQ client?
That's what, no, in case of a there doesn't need any much functionality about the MQ. Only they wanted to put or to get a message.
Okay.
So then they will go for the clustering. Yeah, this one MQ client.
Okay, okay. From there, and what they should do, like if it's
they can get the message. That's it. They cannot do more.
They'll create local queue manager, no?
No, local queue manager. Why? See, he will connect to the remote queue manager only always.
Okay, okay, got it.
The locally queue manager is existed. Why client is required now? No client required.
Yes. So they'll install MQ client and create remote queue. Like create means like they'll connect to remote queue.
Yeah, connect to the remote queue. Yes, you are right. I have already existing environment is there. My new applications are they're going to be communicated over the network. Now new application they doesn't need much functionality. Only they wanted to put message and they want to get message. They do not have multiple. There are so many applications. I have, I think so, 1 or 2 applications. So for 1 or 2 applications they cannot expand that license, right? Because if you are installing MQ on a client MQ any system, So there will be charge based on the process per unit. Okay, so it is actually waste of that client. It is waste of that licensing. They're spending so much money for that for MQ to install. To reduce that costing and to reducing the management also, administration also, the better is always go for the MQ client. MQ client is which is a freeware software and isn't required any licensing. So you can connect to the existing MQ infrastructure.
Okay.
Okay.
If there is a .NET application, okay.
Any .NET or whatever it may be. So we need to install MQ client.
Okay.
And we can able to connect. Simple. Now there are two queue managers are created now, CRT MQ yeah. Start STRMQ. So now three queue managers are running. Let's go to the queue manager A and define the required objects. First define listener. My listener name is QMA dot TCP TRP type TCP control QMGR port 1414, make it 1414. Control is mistake and CONTROL. Now start listener QMA.TCP. Now let's define the channel. My channel name is QMA.SVR. Channel type is SVRCon. MC user ID is MQM. Now done this one. Alter QMGR CHLOG should be disabled. Okay, it is QMA side done. Now let's go to QMB. QMB already we have created the respective things and we'll verify that one. Display CHL. My server connection channel name is what is the test.svr. We will create new one, no problem. Define channel. Channel type is QMB.svr. Channel type is SVRCon. Okay. MCA user is MQM. I will explain about this MCA user. So define, this is done. At the queue manager B side also done. Let's go to the queue manager C. Define listener 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 QMB dot TCP PRP type is TCP, port is 1416, control is QMGR. Start listener QMB.TCP, display LS status, listener is running. Alter QMGR CHLOG should be disabled for time being. Now all the places we have created channels. Now we need to create a client connection channel. As I told you, queue manager B is the geographically middle. We will create the queue manager B. Go to the run MQSC queue manager B and define channel. My channel name is qma.svr, channel type is clnt con, client connection, con name is 192 192 162 198 what is 192 168? Okay, 192 168 152 134 1414 is the IP address of the queue manager A, and QM name is queue manager A. Done. Next, define channel qmb.svr, channel type is clnt con name is 192 168 152 134 1415. QM name is QMB. Okay. Define channel QM what I created channel name at the QMB. For QMC I have not created channel. I will create channel later. No issue. QMC.svr, channel type is CLNT con name should be that 192 168 152 134 1416. QM name is QMC. Now go to the queue manager C and define channel. Define channel. My channel name is qmc.svr. Channel type is svr con. MCA user is MQM. Done. Now go to the /var mqm qmgrs particular queue manager B and at the rate ipcc here file name called amqclchl.tab file. So we need to copy this amqclchl.tab file to the client. Now I have a secure file transfer. I can copy from my local system to my remote system to local. Let me connect to the 192 168 152 134. You can use this root user to copy. Go to the /var mqm qmgrs under queue manager B under @ipcc. Take here under the client. You can remove existing one. Copy this one. It is done now. Now set up the environment variable here. Just close this one. Take new command line. Set mqchl library equal to D drive CLNT client. It should be client. Yeah, this one. Set mqchl tab equal to the tab file name. Okay, done now. Let's try to put message of the queue manager A, queue manager B, and queue manager C. Run MQSC, queue manager A, define queue local QMA.LQ, define QC, define queue local QMC.LQ. Now let's try to put message one of the queue manager A.LQ. AMQS put C, queue name is QMA.LQ space queue manager A. We are able to put message. See, we are able to put message. Now let's try to put message QMB.LQ under queue manager B. Yes, we are able to put message. Next queue manager C, queue manager C.LQ. Yes, I am able to put message. So this is how we can verify by putting a message. Let's go and verify. Yes, I can see that 5 messages reached. Let's go to the queue manager A, display QS, QMA.LQ. 6 messages. Queue manager B, display QS, QMB.LQ. I can see that 4 messages. So this is how we can do the channel table definition. You got it? Yeah. Okay, Mahesh and Deepak, you can practice from your side. So this client server communication. So tomorrow we'll see the new concept. Okay, date letter handler.
Okay.
So tomorrow we'll see that new concept, date letter handler concept.
Okay. Okay.
Okay.
Thanks, Ram.
Yeah. Good night.
Good night.
Mahesh? Mahesh?
Yes, I'll call you.
Oh, okay, no problem.
Yeah, Ram.
Okay.